Hello everyone, welcome back to the Microsoft Java YouTube channel. In this video, I'm going to be walking you through how to deploy a simple Hello World container to Azure Container Apps using Terraform and AZD. If you have never heard of Terraform before, it is an open source infrastructure as a code tool by HashiCorp. Essentially, you write config files that describe your cloud resources, and Terraform automatically spins them up or spins them down in a consistent way. Another Microsoft-specific alternative for infrastructure as code is Bicep, which simplifies ARM templates. But in this video, we're going to be focusing on Terraform because it works across multiple clouds and is extremely popular in the DevOps world. We're going to be assuming you already have Terraform installed on your machine, the Azure CLI installed, and you have run AZD login to authenticate with Azure. So let's go ahead and dive in. The very first thing we're going to do is create a folder for our Terraform files. So let me go ahead and share my screen. You do now see my VS Code. So we'll make a directory, make directory, and we'll call it ACA demo TF. And we'll go ahead now and open this folder in Azure. Okay. And we now have that open the terminal. So we're now going to go ahead and create a file called main.tf, which will house all of our configurations. The main.tf will contain all the configurations required when we are actually deploying our ACA instance. The configuration file itself is quite long, so instead of boring you and walking through line by line, I have already prepared a Terraform file for you, which you can reference using the GitHub link in the bio. So let's go ahead and get started. The first section that I have pasted in is telling Terraform to use the Azure Resource Manager, Azure RM, provider at version 3.40.90. This ensures our code matches the newer syntax for Azure Container Apps, and we also specify our Terraform CLI must be at least version 1.3.0. This sets up the Azure provider with the default features. Next, we're going to go ahead and set up some variables which we'll use when setting up the rest of our configurations for deployment. Here we have 5 variables. We have location, which is set to default, which is East US. We have the resource group name, which is set to RG ACA hello, the environment name, ACA env demo, the container app name, the container image. The container image is a basic image sample from Microsoft, which just is a sample hello world page. You can easily change any of these defaults or pass them at runtime as well. Next, we're going to go ahead and create our resource group. Let me go ahead and paste that in. So you can see now we're starting to pull the variables that we had just defined, and we're pulling these variables to initially create our resource group. So we have resource group name and then location. Now we're going to be defining all of our other Azure resources. We're going to add a log analytics workspace. So let's go ahead and paste that in. Azure Container Apps requires a log analytics workspace to collect logs. So we're creating one here, appending -law to our resource group name. We choose the PER GB 2018 SKU and keep 30 days of logs. These are just defaults. You are more than welcome to change these. This is what just works in the default setting. Next, we're going to be defining the container app environment itself. So let's go ahead and paste that in. This creates the container app environment, the hosting environment for one or more container apps. We pass in the log analytics workspace ID from the workspace we just created. This environment must be in the same location as our resource group. And you can see how the ordering actually matters in this case in the Terraform file itself. Next, we're going to be defining the container app. So here we can see this is the actual container app. We have the name, which is pulling again from the variables that we defined at the top. In this case, what had we set our container app to? Container app name, ACA hello world -terra. In addition then, We have the environment ID, the resource group name, and now finally we have some more interesting things. We have revision mode set to single, which means we only keep the latest revision active. We have the ingress block. We have external enabled equals true, which makes it public such that we can access it. We have the target port set to 80. This is where our container listens. Traffic weight sets 100% of our traffic to our latest revision. And finally, we call it Hello Azure. It uses the image that we have set uh, again in the variables section of our Terraform file. Here we can see that we are setting other defaults, again, like the name, the CPU, memory. All of this can be changed depending on the specific needs of your application. Lastly, we're going to add an output such that it is easy for us to access the application when it is live. It'll just print out the fully qualified domain name of the container app, and this makes it easy to copy and paste into our browser to test. So now we get to the fun part, which is where we get to deploy our application. So go ahead and make sure that you save the file, and we're going to run Terraform init, initialize. And what this does, it downloads any required provider plugin. So we can see it ran successfully. Next, we're going to run Terraform plan. Terraform plan shows you what resources will be created or changed. It's like a plan. So we'll wait for that to run. We'll double check everything that it's planning on doing before finally applying the plan and deploying. And there we go. Sometimes the plan command can take a couple moments to run. We can see an output that is outlining all the actions that will be taken when creating our resources based on the Terraform config that we provided. We're not going to read through all of it. You can read through it at your own time. It's quite interesting how it breaks it down. But at the end of the day, it's essentially a more user-friendly version of our configuration file printed out in the terminal such that we can validate. Finally, we're going to run Terraform apply. Terraform apply actually provisions the resources in Azure. So let me go ahead and run Terraform apply, and auto approve just skips the approval step such that we go straight to the deployments. And once again, it might take a couple of moments, so we'll be back once we are done running this command. All right, and we are back. So we can see that our resources were successfully deployed and the container app URL has been printed out here at the bottom. We'll go ahead and copy that, and we'll open up a browser and paste it in to double check our deployment. So in this case, we can see your container app is running with the hello world image. And there you have it. We have successfully deployed a container app for anybody in the world to access. So now we're going to be cleaning up the resources in order to avoid charges. We'll run a command known as Terraform destroy. And it's essentially just going to delete everything. Terraform will ask you to confirm, and after that, it removes the resource group, container app, log analytics, the container app, and everything else in between. And that's it. While that runs, I want to conclude and summarize everything we did. We used Terraform to build a simple Hello World container app on Azure. In the process, we also saw how Azure Container Apps requires a log analytics workspace for logging, plus a dedicated environment. If you'd like, you could achieve the same with Bicep, Microsoft's own infrastructure as a code solution, but Terraform is great for cross-cloud or multi-cloud setups. Thanks for joining me in this tutorial. If you found it helpful, like, subscribe, and stay tuned for more cloud content. Until next time, happy coding. See you all.